Yeah, AC machine is divided into two categories. One is the induction machine and another one is the synchronous machine. All these are AC machine. Okay, what is the difference between the induction and the synchronous? In induction machine, where we are having variable speed. Okay, we are having variable speed, and for synchronous machine we are having constant speed. So this is the main difference. Like you are using fan at your home, right? You can change the speed of your fan. So then that you are using induction machine. And in our home, which supply we are using? Single phase or three phase for our home? But generally at home it is single phase, and for industries we'll use three phase. So fan which we are using it at our home, that is of single phase induction motor. Okay, mainly the main difference is for induction machine where we can change the speed, and for synchronous machine we can't change the speed. Okay, now next part is basically the working principle of induction machine, or we can say induction motor. Basically induction motor depends on, like tell me, in induction motor will provide which energy? Can you tell me? इंडक्शन मोटर में हम कौन सी एनर्जी देते हैं? मोटर है, so we are providing electrical energy, right? And that electrical energy is converted into mechanical energy, right? So see how it actually works. Suppose this is a you know that in every machine we are having two parts. One is the stator. Stator is the stationary part, and another one is the rotor. Rotor is the rotating part, right? And if it is of three phase induction motor, we are giving three phase supply. One supply is R, another supply is Y, another supply is B. Okay, this is for I am telling you for the three phase induction motor. Clear? Up to here it's clear. So, if we are talking about the three phase, first you should know what is three phase. Three phase means the three wires. One starts from zero, right? Another wire starts from the positive, like this, and another wire starts from the negative, like this. Okay. So, if I'll complete the waveform, it will one starts from the zero, another starts from the negative side, okay, like from here, and another waveform starts from here, from this side. So there is a gap of around 90 degrees in each. Okay, so if suppose it is R, this is Y, and this is B, so what we can say that R waveform starts first, then after that Y waveform start, then after that B waveform start, correct? So पहले R start हो रही है, फिर Y start हो रही है, फिर B start हो रही है, and you know that whenever there is a current carrying conductor, that will always produce magnetic field, correct? That will always produce magnetic field if there is a current carrying conductor. तो पहले इसके according R में current जा रहा है, तो so we'll have magnetic field at R, right? Then we'll have magnetic field at Y, then we'll have magnetic field at B, right? करेक्ट? तीनों पे एक ही टाइम पे तो मैग्नेटिक फील्ड जनरेट नहीं होगा ना, अलग अलग टाइम पे हो रहा है। पहले आर में हो, फर्स्ट द करंट इज फ्लोइंग इन आर, तो पहले आर में मैग्नेटिक फील्ड जनरेट होगा, देन करंट इज फ्लोइंग थ्रू वाई, देन वाई में मैग्नेटिक फील्ड जनरेट होगा, देन करंट इज फ्लोइंग थ्रू बी, देन बी में मैग्नेटिक फील्ड जनरेट होगा, करेक्ट? Clear up to here? So here similarly in this case, first the current is flowing in R, suppose R में magnetic field generate हो गया यहाँ पे at this place. Now the current is flowing in Y, suppose the magnetic field is generated for Y at this. Okay, now the current flowing is B, suppose the magnetic field is generated at B is near to this. Okay, so it seems like that magnetic field is rotating. Okay, it seems because first magnetic field is here, then magnetic field is here, then magnetic field is here, then again here, here, here. So it seems like that the magnetic field is rotating, and that concept is known as the RMF. That concept is known as RMF. What do you mean by the RMF? Full form of RMS is the rotating magnetic field. rotating magnetic field. Okay, understood? Now in basically this induction motor works on RMF only, rotating magnetic field. Why we are having rotating magnetic field? Because we are giving three phase supply to the stator. If we will not give three phase supply to the stator, then in that case no RMF will be generated. Clear this thing? Any doubt up to here? Now see, this is the stator on which rotating magnetic field is generated, but on the rotor is still stationary, right? Rotor is still stationary and it is not rotating till now. अभी तक वो rotate नहीं कर रहा. So if there is a stationary conductor in between and the rotating magnetic field is rotating, so it will cut the magnetic flux or not? It will cut na? It will cut the magnetic flux. So according to Faraday's law of electromagnetic induction, Faraday's law of EMI, he states that E is equal to minus N d phi by dt. What do you mean by the d phi by dt? D phi by dt is the change in flux with respect to time. Correct? Change in flux. If he what he says that if there is a change in flux with respect to time, then in that case EMF will induced. If there is no change in flux, then no EMF will induced. Okay, now what happens is what is going to happen in this case? Here magnetic field is changing but the rotor is stationary, so magnetic field lines will be generated, right? And if magnetic field lines will be generated, then magnetic flux will change obviously. So according to Faraday's law, EMF is induced, right? And this EMF is induced in the rotor. Okay, if EMF is induced, then there is a current flowing in the rotor, correct? If EMF is induced, then there is a current flowing in the rotor. So let us suppose there is a current flowing in the rotor. Now still up to here also rotor is not rotating, right? So if the current produced in the rotor, then it will also produce magnetic field, correct or not? If there is a current flowing in the rotor, then it will also produce magnetic field. Now you can see that there are two magnetic field. One is the magnetic field of stator and another is the magnetic field of rotor. Will these two magnetic field interact with each other? These two magnetic fields will interact with each other. Obviously they are they are very near to each other, so these magnetic field will interact with each other. Now who can move, rotor or stator? Rotor only the move because stator तो stationary है. Rotor is the like rotating device, so rotor starts rotating. Why? Because there is a force exert on the rotor due to the interaction of two magnetic field, right? So if stator moves in the clockwise direction, then rotor also moves in the clockwise direction. Okay, now see how it's going to be happen. Like this is stator and internal one is the rotor. Now you can see that the rotating magnetic field is produced on the stator. Like suppose magnetic field is here, magnetic field is here, and magnetic field is here. So what happens, due to this magnetic field EMF is induced in the rotor, and due to the production of EMF there is a production of magnetic field, and these two magnetic field interact with each other. Like suppose here north pole is generated. Okay, now magnetic field rotate, now the north pole will come here. Okay, and suppose here on the rotor side there is a generation of south pole. Okay, there is a generation of south pole. So what will happen, south will attract towards the north. Now so south also wants to move towards the north, but meanwhile इतने में north कहाँ पहुंच जाएगा, here. Then south यहाँ से कहाँ पहुंच जाएगा, here. South will move. Now in the meantime north will move towards here. North यहाँ पहुंच जाएगा. फिर इतने में south यहाँ north के पीछे आएगा. North आगे भाग गया. South कहाँ पे जाएगा, उसके पीछे पीछे जाएगा. फिर से नॉर्थ भाग जाए, मतलब भाग जाएगा. फिर से इट्स लाइक जस्ट लाइक अ चोर और पुलिस. जैसे चोर आगे आगे भाग रहा है, चोर इतने में यहाँ आया, पुलिस उसको पकड़ने के लिए उसी जगह पे आती है, इतने में चोर क्या हो जाता है, आगे वाली जगह पे भाग जाता है ना? तो इसीलिए जिस डायरेक्शन में चोर जाएगा उसी डायरेक्शन में तो पुलिस जाएगी, राइट? तो जिस डायरेक्शन में स्टेटर जाएगा उसी डायरेक्शन में will have rotor. If both will move in clockwise or either in anti-clockwise direction. Clear this? This is the basic principle of three-phase induction motor.